This video is about the derivative of natural log. So, people were asking me to make some update videos on calculus, so I thought of making a video on the derivative of natural log because while deriving the derivative, you will learn a lot of things about derivatives and you will learn a lot of things about the conditions on x which apply in the derivation of natural log. I learned that in my recent exam, so I wanted to teach you that. And I will teach you in a very easy way. We will plot the log x and 1 upon x later using a graphic tool, and then you will learn a lot of things about how domains and ranges affect the functions. So first let's derive it from the definition of derivatives. So let's get started. Now we know that f dash x is given by limit delta x approaches to 0 f of x plus delta x minus fx divided by delta x. Now we will our function is log x, so we will chunk in log x in place of the function. So d by dx of ln x. Now I am writing log as ln to say that it's the natural log to the base e. So ln x is equal to limit delta x approaches to 0 ln x plus delta x minus ln x divided by delta x. Now ln is our function and x plus delta x is from the definition. Now if you watched my video on logarithms, then you will probably know that ln a minus ln b is equal to ln a divided by b. So we will use that property in here. So limit delta x approaches to 0 ln x plus delta x divided by x, and we can write this delta x here 1 upon delta x. Why I am doing this is because I also know that a ln b is equal to ln b raised to the power a. So limit delta x approaches to 0 here ln, I will use this bracket, x plus delta x divided by x raised to the power 1 by delta x. Now further we can solve this to write, I'll use this one. So limit delta x approaches to 0 ln x divided by x is 1 plus delta x divided by x in this bracket and 1 upon delta x. Now here we will use the tricks. Think like the person who was deriving this thing. I think he was thinking to make the inside thing as the definition of e. And you will probably know that e is defined as e is the exponential c log base e. Yes, this e. This e is defined as limit delta x, or let me say another, I will write n approaches to 0 1 plus n raised to the power 1 by n. I think he wanted to make this thing as this, and then you know that ln e is 1, and then whatever we will get is our answer. So let's try to make that things. So remember, when you are deriving something, try to think like that person who was first deriving the thing. That's how you remember math. uh, if you can cram this, like you will take this delta x here and do that, but you will remember that for exams. If you want to remember that for your whole life, then you have to think how the process was. So now see this, what we are gonna do is we want to make this thing like this. So what if we put this as n? So let us put n is equal to delta x upon x. So we get delta x as nx and we also need this, so 1 upon delta x as 1 upon nx, and uh, 1 upon x and x we can write as 1 upon n dot 1 upon x. Now you can see this 1 upon x, right? This is our answer. It will come outside and everything else will become 1. So this is from where you get 1 upon x. So now also one thing, we have done some substitutions, so we will change the limit also. So if delta x approaches to 0, then n also approaches to 0. Okay, so n and delta x are equal, so they will also approach in the same way. So now make this equal to a little down, so we get limit n approaches to 0 ln 1 plus n from here raised to the power 1 upon n, and I will write this 1 upon x in here. This is the one and the same thing. Now we also know that ln a raised to the power b is equal to b ln a. So this 1 upon x come outside, and also see limit is to n, not x. So x can come outside of the limit also. So we get, I will write this with this marker, 1 upon x limit n approaches to 0 ln 1 plus n raised to the power 1 upon n. So see this thing, we get something like this. So now you will probably notice that the function, this is n, this is something like it's looking like the function is this limit affects n only, not log. So we can take this limit inside this also. So 1 upon x limit ln outside. Let me do this in another way so you can understand it better. So I will write 1 upon x ln, and inside I'll use another marker, limit n approaches to 0 1 plus n raised to the power 1 upon n. So we get this thing. This is one and the same thing. So we get 1 upon x ln e inside. And what is ln e? It is 1. So we get 1 upon x. So now we got our answer. So what we got is this. We got d by dx of ln x is equal to 1 upon x. So this should be our answer, right? But it is not. It is not our complete answer. We have to see some more things, and that's the new things you will learn probably if you don't learn that by your teacher. So see this. Log is a function which can take only, this is a number line, this is positive and this is negative and this is 0, right? So here x can take only positive values because log function is not defined for negative or 0. But here x is only not defined for 0. It can take negative values also and positive values also. So we have to do something so that the domain, which is are the input values, become same for these both things. So now if we say for x greater than 0, only for x greater than 0, d by dx ln x is equal to 1 upon x, right? Now also one thing, that you can also take here mod of x, because if you take mod of x, then the values automatically become positive. Now let's make graphs and understand what this tells us. So here is a graphing tool. See this, I will take this here, so you can take this. Now see this, I plotted y is equal to log x. This is y is equal to log x, and this is 1 upon x. So now one thing you can see that is this does not give you any output values, right? So we will take a condition here which is x is greater than 0. So it is showing this part of the graph, right? So this is what we need. Now I will also show you how mod x looks like. Mod of x. So we get this. Now you can see that before we only got these things, right? But now we also have this one also, because now it is defined for negative values also. Now if we remove this condition and in this we write as, this is a keyboard for my tablet which comes whenever I type x. Wait a second, I'll use this x. So see this, now our domain and range becomes equal. So also now you can also see that uh, the slope of tangent, the derivative is known as the slope of tangent, right? So this is our log x and this is its slope. This is showing the function of its slope. So at here, when you know that, wait a second, this is my tool. So you know that the slope of a vertical line is not defined. So as this is approaching to straight line, our slope is also not defined, it's infinity. And like here we are getting slope 0 0 0 as it goes off. After this the slope becomes 0 as this line is making parallel to x-axis. So I think that you must have understood derivatives better. This is a little slow. This tool is known as Desmos. I use it a lot to make graphs. I also made a special video on this. So from here I thought your understanding of derivatives must be a little better. So let me make this the right window here, right? Okay, so this is how you derive the derivative of natural log. So thanks for watching this video. I will thanks here, and always remember that math is everything and it's also interesting.